Hi everyone! Today I wanted to show you a technique for rendering seamless outlines around 3D models. The core of this technique is a shader pass that takes the mesh, extrudes it along its normals, and renders it as a single color. The model is then rendered normally on top of this base pass, and the effect is essentially complete. This is a well-known technique, and my implementation is based on an outline shader from the Unity website. A link will be in the description. The problem with this technique is that it creates strange artifacts around hard edges on the mesh. Let's get some background as to why this is going on. By default, all vertex properties are interpolated between vertices. If for a given triangle, not all the normals are pointing in the same direction, for any pixel within that triangle, the normal for that pixel will be somewhere in between the normals of each vertex. This allows objects to appear smooth, even if they only have a few vertices. Under this system, to create a hard edge, you have to create duplicate vertices that have the exact same position but different normals. The interpolation still occurs, but because for all the vertices on a face, the normals are pointing in the same direction, you get flat faces and hard edges. This is great for most rendering scenarios, but for our outlining example, it's a serious problem. When we extrude faces based on their normals, hard edges appear to come apart. To fix this, we need a way to tell the shader in what direction to extrude each vertex such that these duplicate vertices move outward but stay together. I learned the following technique from watching a GDC talk by one of the technical artists behind Guilty Gear Xrd. They did an amazing job creating a 2D anime feel using 3D models, and part of that success came from their approach to outlining. It's an extremely interesting talk that I highly recommend to anyone interested in alternative rendering techniques. I'll include a link in the description. The idea is to go through the mesh and find all the duplicate vertices, which is to say all the vertices that have the exact same position, and average their normals together. The result is a new normal that still points outward. We can assign this new normal to each of the duplicate vertices to keep them together when we extrude them. We can't assign this new normal to the vertex's normal channel, as that would affect the regular rendering, so we need an alternative place to store this information per vertex. The solution is to use the vertex color channel. Even though it was originally intended to store colors, it's simply 4 float values between 0 and 1, which is the same format used to store a normal. Vertex colors are rarely used in modern applications, so this approach shouldn't interfere with your rendering process. I'm sure it's possible to write an extension to do this normal averaging within a 3D modeling program, but because I'm most familiar with Unity, I created a C# model behavior that takes in a list of meshes and does the normal averaging when the game starts. I won't go into the details of how this script works, but the full project, including the script and the shader, are available on GitHub with a link in the description. In the vertex shader for the outline pass, we are able to modify the position of vertices before they are rendered. In the basic outline approach, we add the vertex's normal to its position. This extrudes the vertices and produces the artifacts on hard edges I mentioned previously. Here we can make use of the averaged normals we saved to the vertex colors. This produces the result we want, a seamless outline that looks appropriate from any angle. That's basically it. One remaining issue is saving the vertex color data. Because we set the vertex colors at runtime, they will be lost when we quit the game. There are several exporters on the Unity Asset Store that allow you to export meshes while the game is running. It turns out OBJ exporters won't work because Unity's OBJ importer doesn't support vertex colors. I had some luck with an FBX exporter, but Unity's FBX importer doesn't support negative vertex colors. I said before that normals and colors are stored the same way, but normals are often negative, while colors rarely are. To get around this, you could convert the normal values which go from -1 to 1 to values which go from 0 to 1, and save that to the FBX, then convert the values back to -1 to 1 in the shader vertex function. If you want to learn more about shaders, and I mean a lot more, check out Cat-Like Coding's tutorial series. Thanks for watching. If you found this video useful or interesting, please give it a like so more people can see it. Bye!